Hey everyone, welcome back to Code with Kerry, and today we are going to learn about deleting a linked list. So, this is a linked list we have here. 10 is pointing towards 11, 11 is pointing towards 12. So this is the head node as of now, and this is pointing towards null. Now, what if I want to delete this node right here? This node, this node. So the first thing which comes to mind is we will have to delete this link. Means this has to go to null. Right. And the second thing which will happen is this head node, head will shift to this now. Yeah, right. So, yep. Now we have the solution for our first question. Okay, so let's start coding. Okay. Okay. This was a code if you remember. By the way, I'll put the GitHub repository if you want. So I'll write a function deleting by the name of deleting. What we'll be passing is we'll be passing a node means head. Also the position at which the node is we have to delete. And what else should pass? Okay, let's see. This is it, I guess. Okay, so now for the head we saw it. Like for head, what we have to do is we have to just move the head forward, and there's this delete this link right here. So okay, so like if I do if the position is equals to 1, then what do I have to do? Then what do I have to do is I'll make the head as template node. Temp is equal to head. So yeah, temp next. Also wait for that. I'll just move increment the head. Head is equal to head next, and temp next goes null. Temp next goes null. Yep, that is it, I guess. One more thing. We'll have to delete, free the memory, right? Delete node. So delete temp. By the way, we'll have to write a destructor. Like we have a constructor here, right? So to free the memory, what we'll have to do is I'll just write a destructor. Destructor. Yeah. So the syntax is like this. So what are the parameters we have to pass? We have to pass. I guess nothing. We don't anything. So I'll just make sure we have the value. This dot value. By the way, I do say value because I usually code in Java. If uh, the next node, if the means the pointer goes null, if the pointer goes null, what we'll be doing is we'll be freeing the memory, freeing the memory. Well, why is this showing as a class has no where is value? Let's see. Yeah. So we'll just delete next, and then they should point towards null. Yeah, right. We means it will be null type. So just to make sure that the memory is free, we will see out it memory free. Yep, that is it. Do have an issue like why is this class node has no member value? It says, oh, it's because it's data, right? Yep. That. So yep, let's go now. We just free delete it. We have deleted it, but now so we have done it for the head condition. We have let, before that we'll just check it if it works or not. So insert, not insert. We are deleting. What all we have to pass? We have to pass head and position as 1. So right now our head, before that we'll just print out, we will just see what is our head right now. Okay, so head is 1. Okay, right now head is 1. So after deleting it, we'll just see what it is. Awesome. See, now memory freed. Let's go. So head has now become 7 and 1 got deleted from our memory. Awesome, nice one. So now, what if I want to delete a node in the between? Like suppose we have to delete a node at position 3, this right here. This node, if we have to delete, what do you think we'll have to do? So for this, to delete this node, we'll have to make sure that this point towards this, right? And so we'll have to delete this node. This should point towards this. So what according to me we should do is we'll take two variables, two nodes, pointers, previous and current. So what we'll do is we'll make previous come till here, the node before the current node, and this will be a current node, previous and current. So initially what we'll do is previous will point towards null and current will point towards head, right? So now once we reach here, what we'll do is we'll make previous point towards uh, point towards current connects node. So once we are done with this, we'll make current connect is equals to null, and then we are free to free the memory. So we'll just delete current. So right, let's go. Okay, else what will I do is I'll make a previous node which will point towards null, and we'll make a current node which will point towards head. Yeah, right. Yeah, awesome. So also we'll have to traverse a linked list. We'll make sure we have a count. I'll start it from 1. So while count is less than the position, while count is less than the position, what we'll do is uh, we'll just increment them. Previous is equals to uh, current, and current is equals to current connects. All right, and one more thing, I guess. Count plus plus. Yep. We'll have to increment the count also. So now once we reach at this node, what we'll do is previous ka next, previous ka next has to point towards current ka next, and once this is done, current ka next will go null, and we can just delete current easily. Delete current. Awesome. Now there's one more thing, that what if it's the last node we are deleting, right? So if we are deleting the last node, so if current ka next goes null, means if it's the last node, then we just have to update the tail. So tail will be equal to previous. Nice. Also we'll have to mention about tail here. Node tail. Awesome. So let's go. Let's hope this works out. So delete it. So this is position 1. What was that? Tail we are passing right. So one more thing. What if I'm deleting? Uh, I'll pass head. I'll delete position and element at position 3, right? And we have to pass tail. Awesome. Oh, I forgot to yeah. Now we'll try to delete element at position 2. See, 22 was here. It was deleted. Awesome. Let's go. Nice one. So this is the code we have. This is generic code you can say, which we have for the whole linked list, whether you want to insert, delete, or do anything with it. So here we finish with a single linked list. Hope you enjoyed the playlist. Thank you guys.